Okay, we're still on section 2.3 on lines, and we looked at the point slope form for the equation of a line where you have a point and the slope. The second equation that we use to write equations of lines is called the slope-intercept form. This one may be more familiar to you. An equation of a line with a slope m, and now we don't just have any point, we have the y-intercept, and this is our y equals mx plus b, where the slope is m. It's not mx. I've seen people tell me the slope is 2x or something. The slope is m. The x is a variable, and b is our y-intercept. It's a particular place on the graph, not just any point. Okay, so this is a lot of our problems will say to put your final answer in slope-intercept form, and that's what it means, where it's, in other words, solved for y. Y is by itself, everything else on the other side. This is slope-intercept form. Here's a definition. The equation of a line is in general form, or sometimes called standard form, when it is written as ax plus by equals c. So this is another format that we may be asked to leave our answer in. If we're asked to find the equation of a line, they often say leave it in slope-intercept form, or they say leave it in general form, or as our problems here will say, our examples, both. So we need to understand both of these. Now, note that a, b, and c are integers, and a and b are not both 0. If they were both 0, of course, they would be canceled out. What do we mean by integers? Okay, well, integers are not rational numbers. They're not fractions. So if we have like 1/2 x or something, or 2/4 y, or 2/3 y, or something like that, we will have to clear the equation of fractions to get it in general form. Okay, so this is important. Your answer will be counted wrong if you have fractions here for a, b, and c. They must be integers. Okay, use the point slope form of a line and identify horizontal lines. Find the equation of the line that passes through 4, -3 with a slope of 5, and then we'll write it in both formats. Okay, so we're given a point and the slope. The point slope form is y minus y1 equals m times x minus x1. Okay, y minus y1 is -3, m is 5, x1 is 4. So this is not the final result. It needs to look like this and then like this. So y plus 3 equals 5x minus 20. We'll subtract 3 to solve for y. Y equals 5x minus 23. So there is our slope-intercept form. And now we need to get it in this format. So what do we do to get it in that format? Well, we need the x and y on the same side. So I'll subtract 5x from both sides. And I have -5x plus y equals -23. And here is my general form. Notice that a, b, and c are all integers, -5, 1, and -23. Okay, this one time, for this one example, I'm going to show you, and you may already be thinking of this, another way to do this without using the point slope form. You may have been taught this way. I think it's perfectly fine, so I want to show it to you just to confirm that this will work. And that is to use slope-intercept form. So this is an alternate solution, an alternate method, and we're going to use y equals mx plus b. Okay, so in this case, I have the point 4, -3, and the slope of 5. So y is -3. Let me just write y equals mx plus b. Okay, so y equals m times x. What do I not know? I don't know b. Okay, so I can plug in the point xy, I can plug in the slope. -3 equals 20 plus b minus 23, minus 20. Don't know why, I'm getting ahead of myself on that. Minus 20, and I get -23 equals b. And we were supposed to put it in slope-intercept form, so y equals, I know m, 5x, I know b now, negative 23. So that's a nice way also to get to the same result. And that's perfectly fine to do that. But I'm going to continue to use the point slope form to do any other examples because that's our directions, but I find this to be perfectly acceptable. Okay, example 5. Use the point slope form, identify horizontal lines, find the equation of a horizontal line containing the point 1, 4. What do we know about the slope of a horizontal line? We need to know that by now. It is 0, right? And you can plug 0 into an equation. We can't plug the word undefined, but we can plug 0. So let's use y minus y1 equals m times x minus x1. y1 is 4, m is 0, x1 is 1. Y minus 4 equals what's 0 times anything? It's 0, right? Add 4 to both sides to solve for y. Y equals 4. There's the equation of a horizontal line. Remember, look back at that. Y is 4. All of the y's are 4. X is all real numbers. That's our horizontal line. Now, if you're given directions to find the equation of a horizontal line containing the point 1, 4, and that's it, and of course you don't have to use this because you should be able to look at that and say, well, the equation of a horizontal line is always y equals some constant number. If it goes through 1, 4, then y must equal 4. So literally you should be able to read that and write y equals 4 and be done with it and not have to do all of this.